Hi guys, today we're looking at de Moivre's theorem. De Moivre's theorem is a very useful theorem in mathematical fields of complex numbers. It allows complex numbers which are in polar form to be easily raised to certain powers. i.e., if z, your complex number in polar form, is or times cos of theta plus I sine theta, then z to the power of n, i.e. I'm raising my z to a certain power n. This can be written as or to the power of n times cos of n theta plus I sine n theta. Let's look at a few examples. Please note that the formal proof of de Moivre's theorem may be asked in the exam. Let's look at question 5, part 1. Use de Moivre's theorem to write the following in the form of a plus bi. We have the complex number 2 plus 2i to the power of 8. The first thing we need to do is write our rectangular form complex number in polar form, i.e. write 2 plus 2i in polar form. To do this, the first thing we need to do is find the modulus. To find the modulus, we find the square root of a squared plus b squared, where in this case a is 2 and b is 2. Substituting these values into our formula gives us or is equal to the square root of 2 squared plus 2 squared, which simplifies to or is equal to 2 root 2. This is our modulus. To write our rectangular complex number 2 plus 2i in polar form, we also need to find the argument, theta. To do this, we find tan of theta is equal to b over a. This gives us theta is equal to inverse tan of 2 over 2. And theta is equal to pi over 4. Please note that theta must always be written in radian form. In this case, our complex number lies in the first quadrant, and therefore our argument is pi over 4. To write our complex number in rectangular form, I substitute my values into our formula of or times cos of theta plus I sine theta. This gives us my complex number in polar form of 2 root 2 times cos of pi over 4 plus I sine pi over 4. I now want to write my complex number. I want to apply de Moivre's theorem. To write 2 plus 2i to the power of 8, we use de Moivre's theorem, which states that or to the power of n times cos n theta plus I sine n theta is the same as 2 plus 2i to the power of 8, where n is our power. Let's substitute our values into our equation for de Moivre's theorem. This gives us 2 plus 2i to the power of 8 can be written as 2 root 2 to the power of 8 times cos of 8 times pi over 4 plus I sine 8 pi over 4. Let's simplify this. 2 root 2 to the power of 8 gives us 4096. We now multiply n and theta. 8 times pi over 4 gives us 2 pi. So we're left with our complex value of 4096 times cos of 2 theta plus I sine 2 theta. We've raised our complex number to a power of 8 easily using de Moivre's theorem. Let's look at another example. Let's look at question 5, part 8. In this case, we're asked to raise the complex number minus 1 plus I to the power of 13. The first thing we need to do is write our complex number minus 1 plus I in polar form. Remember that polar form is or times cos of theta plus I sine of theta. So the first thing I'm going to do here is find my modulus. My modulus is equal to the square root of a squared plus b squared, where a is my real value and b is my imaginary value. In this case, a is equal to minus 1 and b is equal to 1. Substituting these values into our formula for the modulus, we get or is equal to the square root of minus 1 squared plus 1 squared. This gives us or is equal to root 2. We now need to find the argument. Please remember that the argument is the measure of the angle from the positive x-axis anti-clockwise to our complex number. So the first thing we're going to do is find tan of A, where tan of A is equal to b over a. This means that a is equal to inverse tan of b over a, which in our case is 1 over 1. Please note that I am ignoring the minus sign on my real value, as a is a reference angle. This is the angle to this complex number in the first quadrant. Inverse tan of 1 over 1 gives us pi over 4. We now use our reference angle to find the angle, the measure of the angle, anti-clockwise from the positive x-axis to our complex number. i.e., draw up a diagram of where your complex number is. Our complex number minus 1 plus I lies in the fourth quadrant. To find our argument theta in the fourth quadrant, it is 2 pi minus a, your reference angle. This gives us 2 pi minus pi over 4, which is equal to 7 pi over 4. Now that I have or the modulus and the argument theta, I write my complex number in polar form. i.e., we write our complex number minus 1 plus I in the form of or times cos theta plus I sine theta. Substituting our values for or and theta into our polar form formula, we get root 2 times cos of 7 pi over 4 plus I sine 7 pi over 4. We now need to raise our complex number to the power of 13. To do this, I apply de Moivre's theorem. Minus 1 plus I to the power of 8 can be written as or to the power of n times cos of n theta plus I sine n theta, where n is the power that we are raising our complex number to. Substituting our values into de Moivre's theorem, we get root 2 to the power of 13 times cos of 13 times 7 pi over 4 plus I sine 13 times 7 pi over 4. And simplifying this, we get root 2 to the power of 13 times cos of 94 pi over 4 plus I sine 94 pi over 4. Please note that I could also have used an angle of minus pi over 4. So I can also measure my angles clockwise if I want to. Just remember that if you're measuring your angles clockwise, your angle will be a negative value. So this answer could also have been written as root 2 to the power of 13 times cos of 13 times minus pi over 4 plus I sine of 13 times minus pi over 4. But we always keep it to measuring our angles anti-clockwise. This is just to note in case you're wondering why your answer may look slightly different than the back of the book. Please pause and take down this example.